Hi, my name is Rosemary. I'm doing my MSc in Photonics at Center of Excellence in Lasers and Optoelectronic Sciences, Cochin University. Photonics is a science of harnessing light. Here at CELOS, we learn about different areas of light and eventually into the various applications of it. We start with the basics of optics like interference, diffraction, polarization, etc. And later on, we move on to the complex areas like nanophotonics, biophotonics and industrial photonics, in which will be applied all these basic phenomena which we have learned. For advancement in any field, one has to know the basic concepts thoroughly. And for the field of optics, Network of Excellence in Micro-Optics, NEMO, has introduced a wonderful kit. This kit consists of a Class 2 semiconductor laser, a tutorial CD, and 2 identical slides containing micro-optical elements. This is the slide provided with the NEMO kit. To the left-hand side of the kit, we have the diffractive elements or the structures which works on the basic phenomenon of diffraction. To the right-hand side of the slide, we have the refractive elements or the structures which work on the property of refraction. Now, let me explain the diffractive structures. On the top, we have 3 circular structures. These are Fresnel zone plates, which exhibits the property of focusing light, just like a lens. The 3 Fresnel zone plates differs on the basis of focal length. This one is having the least focal length. It is having 10 millimeters. This one is 15 millimeters and this one 250 millimeters. These series of structures and the one here are pattern-forming diffractive elements. These 2 structures are linear gratings and these 2 are crossed gratings. The refractive structures consist of 6 microlenses in the form of an array. The first vertical series shows 2 spherical microlenses. The second series shows arrays of symmetrical lenses which focus light only in one direction, and the last one are hexagonally packed arrays of spherical microlenses. Now, we move on to how to use these elements. Let us first see the patterns that are formed with the pattern-forming diffractive elements. Let's start with the structure at the bottom corner. With this structure, the incoming laser is split into a rectangular square matrix of 16 points, a 4x4 matrix with points of equal intensity. The second pattern-forming structure is the one above the previous one. This one is also similar. In this one, the laser light is split into 8x8 square matrix with points of equal intensity. The third pattern-forming diffractive optical element makes the incoming laser into a circular disc of constant intensity. This element is otherwise called as a flat-top generator. The fourth pattern-forming diffractive optical element is a square grid. The next element shows the Network of Excellence in Micro-Optics logo, and the last pattern-forming diffractive element shows the flag of European Union. The diffractive structures have got 2 simple linear gratings with different pitches. The first one has a pitch of 60 lines per millimeter and the second one has 30 lines per millimeter. The slide also contains 2 crossed gratings. The 6th element on the left-hand side of this slide are microlenses. The lenses shown now are spherical microlenses. The next series are cylindrical microlenses which can focus light only in one direction. And the third set are hexagonally packed series or spherical microlenses.